How about now? Can people hear me? Yes, no, yes, no, yes, no. Somebody, if you can hear me, please ping me in the questions. Apologies. Apparently my headset didn't want to work. Let me quickly go back. Thank you, John, and David and everyone for letting me know that you couldn't hear me. All right, so let's pretend that none of that happened. I'm Shaun Darragh. I'm welcoming you back to day 2 of our Fundamentals of Network Lighting Controls class here in our webinar. The interface is going to be very much like it was last week. So everybody's muted, apparently including me, but now I'm back. If you have questions, please use the questions box. You can use the chat feature too if you'd like, but I'm actually monitoring the questions. I'll stop every 10 minutes or so. Please participate in the polls. Also, following the class, please go ahead and take the short survey. And if you have any questions, go ahead and reach out and let us know afterwards. We are, of course, Lighting Design Lab, a part of the City of Seattle, Seattle City Light. It is very useful for us to be part of the city as we are essentially trying to work through market transformation and have been for many years for lighting controls, and now a variety of other topics. Now, last week I gave you a little bit of homework, and we're going to pause for just a couple of moments before we dive into this. So this is your opportunity now to ask me any questions. I threw a ton of information at you last week, right? We talked about the fundamental concepts of lighting controls, which from my perspective are the circuit, right? How do you get power to the controls or the lights? The control zone, which is the logical grouping of how things are controlled together, dim up, dim down, turn on, turn off, and the scene, right? How do you aggregate all of those things into a unified whole in order for you to be able to understand a space visually, okay? We talked about some of the reasons that we might use lighting controls, right? Flexibility, productivity, energy savings, all of these things. We talked about some of the control strategies that we employ, both the older control strategies, occupancy and vacancy sensing, daylight harvesting, task tuning, astronomic time clock, time scheduling, all these things, and some of the newer ones that are predicated largely on the capabilities of LED, right? Color tuning, circadian potential rhythm, potentially using things to affect our alerting sleep-wake cycles. We talked about dimming 101, right? How do dimmers work? And in particular, how does dimming work for modern LED light sources? If you'll remember, we came to the conclusion that most of the time, the dimming function actually occurs at the light fixture driver level, right? The driver is what's doing the dimming. All of the control systems are simply telling the driver one way or another via a variety of different control protocols that you should go up, you should go down, you should stay in steady state, right? All of those things. So if you have any questions about any of that stuff, now is the time to go ahead and ask me. And to give you a couple of moments to do that, I will say somebody asked me offline last week that I had mentioned something about the lighting control strategies that I was talking about, particularly the old lighting control strategies, which I'd mentioned I'd been teaching them the same strategies for 30 years, and the response was, that can't possibly be. And the reality is it's true. The very first lighting controls class that I ever taught was actually in 1987. And that was for theatrical controls. That was actually how to trim a specific type of dimmer. If you don't know what trimming a dimmer means, don't worry about it. It basically means how the dimmer reacts to an input, when it goes up and goes down, right? So the very first architectural lighting controls class that I delivered was in 1993. And basically all of these same strategies that I talked about have been in employ since before that. So there's kind of nothing new here. The new thing is that it's easier, cheaper, and better than it's ever been before. All right, last chance. Any questions before we dive in? Also, when you're doing that, any questions about the homework? So I'm not seeing any questions. I will tell you that I have given a little experiment for you guys, and I'm hoping to get some feedback on this. Normally speaking, when I teach this class, I do a segment on sequence of operations, right? What is the system supposed to do before I set you loose on the homework? Now, somebody had actually suggested at the class that I taught in Lightfair that it might actually be better to reverse that, to go ahead and release you with the homework and say, what do you think? Go forth, and give you a chance to kind of muddle through with it, and then give you some sense of what I think of with respect to how sequence of operations works. So I'm going to ask you if you guys, after we go through this, I'm about to actually go through sequence of operations with you. If you have a sense, was it better for you to not have the sequence of information first, or was it better for you to have had the sequence of operations first? Please let me know. Fortunately, the homework isn't graded, so it's okay either way. Okay, homework got deprioritized. John, it's okay. Homework is for you, not to be graded. So so this is the project that I left you with. Hopefully everybody got a chance to download it. Again, we had kind of a typical kind of office neighborhood area. We had a small open plan office, a small private office, a small conference room, and then a medium-sized conference room. And I gave you a bunch of information here, right? What are the light fixture types that are represented on the plan here? And I gave you some imagery, both plan style imagery and also 3D, to be able to get a good sense of the space. I also gave you some information. I'm realizing you're not seeing my track here. One second, my spotlight, there we go. I also gave you some information here that gives you the idea of how much light we had initially versus what our target light level was. That, of course, is there to give you the opportunity to task tune, right? To dim the lighting down initially to the target light level so that you're right sizing the light at the same time that you're improving maintenance and also saving a significant amount of energy. All right, so let's talk about this sequence of operations, right? Broadly speaking, this just refers to what is it that you want the lighting control system to do, right? We've specified, we've installed a control system. Now, what does it want to do? All right, well, if we, why are we not going, there we go. If we think back to school days, right? Sequence of operations refers back to algebra initially. This idea of PEMDAS, right? So in order of operations in math, things are in parentheses are done first. Exponents, then multiplication, division, addition, subtraction. We'll all see these things occasionally on Facebook and have a little chuckle about them. But we've got all these things. How are we supposed to know, or how is the installer or programmer supposed to know what the things are supposed to happen, right? So who's going to actually do this? Does the lighting designer say? Sometimes, but lighting designers might not be contracted to do lighting controls. Electrical engineers also might not be contracted to do lighting controls, but they also might not know exactly what the plan was from the lighting designer or the owner. Oops, we're bouncing back through some of this stuff. Architects, owners, factory techs, contractors, who is really going to come up with this information? The reality is that it's kind of the responsibility of everybody on the project, if we're trying to work in a collaborative manner to come up with a good project. It's going to be a little bit different in each case, but regardless, somebody needs to decide up front things like, what are the time schedules, right? Which sensors? You've got sensors that can be occupancy or vacancy. What are they? What are the timeouts, right? How long does a space have to be empty before the lights turn off? We used to say as an average 30 minutes, right? You would have a 30-minute timeout for an occupancy or vacancy sensor. But that was predicated largely on the fact that we used fluorescent lamps. Because fluorescent lamps, if you turn them on and off too frequently, it shortens their lamp life. That's not the case with LEDs. So with LEDs, we tend to be dropping down into 15-minute timeouts. In some cases, I've gone as low as 5-minute timeouts because it doesn't matter from a lamp life perspective, but it can have significant energy implications. What are the switches and dimmers? How are they tied to the zones? What are the zones in the presets? What are the daylight zone characteristics? And are there any specialty characteristics within the space? All these things need to be figured out by somebody. And there are a number of different ways that these things can be documented, right? You can have a matrix. I showed you a matrix last week that was very basic, showing types of spaces and the different types of control strategies. I would frequently put something like that in my early documents for, say, basis of design. Eventually, that might become a narrative or a detailed matrix, sometimes a panel schedule or a dimming schedule, a lot of different ways to do this. A couple of examples. Here is a narrative-based kind of sequence of operations, right? This is from, I showed you a picture of the San Francisco Public Utilities headquarters building. This is from the typical private office on that particular project, right? So you'll see that all general lighting will be programmed to automatically turn on as the user enters into the room. So that's an occupancy sensor, right? But it sets the initial level to 50% of light output. Now, this is actually something that is noted in codes now. It wasn't at that time, but there was some research that was done by the California Lighting Technology Center, Michael Siminovich did, where the question was, do we save the most energy by having vacancy sensors where you have to turn the lights on, or occupancy sensors where the lights go to 50% light output? Turned out he found that you saved more energy if you went to 50%, because frankly, a lot of the lighting in the world is overlighted, right? We tend to light for worst case scenarios when we may not need that. So you have the ability, in this case, pressing button 1 is 50% light output, but you can press 2, 3, 4 to get all the way up to 100% light output in those cases where you need that, right? So the reality is most people leave it at 50%, so that reflects that savings there. This also gives us information about the photo sensor, daylight sensor calibration, and the timeout. So basically everything that somebody would need to program a typical private office in this project is listed here in this sequence of operations. A different way to do this is with a more detailed matrix. Now, I gave you all the Excel file that I use for this, right? And basically what we have here is a room number, right, the space. What are the control zones? And I've shown you 3 different ways to annotate them based on the 3 different ways that I showed you last week. Remember, room-based control zones, the control zones that are also potentially room-based or floor-based, and then the building-based, right? So Z2, zone floor 2-12, right? The space type, the lighting type, the target light level. What is the target light level in each one of those rooms so that you can go ahead and task tune accordingly, right? Some information about the lighting control stations. Those are the wall stations. And then the different types of control strategies that we might have here, right? And including things like for occupancy vacancy, for example, what is the timeout, right? So it tells me it's either an occupancy or a vacancy sensor. And then what is the timeout? And then if I have any specialty notes about each space, in this space do this, in that space do that, they come over here and they show up on sheets. I hope this all makes sense to everybody. If anyone has questions about this, go ahead and put them in the questions box. But let me go ahead and show you how I would approach this homework in 2 different ways. 1 second. So a traditional networked lighting control system essentially has load controllers, right? So that they're aggregated together, and we don't have all of the sensors at each light fixture, right? So in this particular case, I have split out control zones as such. I have control zone A and A, right? B, C, and D. Now the reason for that is twofold. One, I have a window wall here, right? So I need a primary daylight zone, and then I need a secondary daylight zone. But I also want to split that up a little bit more so that I can have a little bit finer control. So I split it up along this axis. So these two are in primary daylight zone. These two are in primary daylight zone. These two are in secondary. These two are in secondary. So I have 4 levels of control here that are controlling, 4 zones of control here that are controlling 8 different luminaires. Those are then governed by vacancy sensors here. So vacancy sensor takes A and B, zones A and B, vacancy sensors C and D. And then I have a photocell that tells me how to dim the primary daylight zone and the secondary daylight zone, right? We go into the private office. I have a vacancy sensor here, and I have one control zone that is dimmable. If I go into the team room here, I have a vacancy sensor, and I have one zone. Remember, I don't want to have different types of light fixtures in the same zone, so I'm dimming the wall washers separately from the decorative pendants. Same thing in the large conference room, right? Now in this case, I put a vacancy sensor on the wall. I could do it on the wall or I could do it on the ceiling. Here I've got it in the ceiling. Vacancy sensor on the wall, vacancy sensor in the ceiling, daylight sensor, right? Now, what does these mean? So I tend to like to note lighting control stations, right? So rather than just a little switch with a symbol in it, I will annotate lighting control station 1 right here, looks like this. I have a 2-button station, basically on, off, right? And then I have 2 devices here that give me a little bit of scene control and then raise, lower, up and down, right? In the office, I might have 4, or in this case, actually 3 scenes. And I'm using different manufacturers' gear so that you get a sense of what different different manufacturers might look like, or some of their different capabilities. In the team room and the conference room, I'm using these presets that you'll notice are actually annotated as to what they are specifically. You'll notice there's also a raise lower button here as well as an on off. So essentially this will give you sort of some sense of how I would approach this from a networked lighting control standpoint, right? Basically the idea that we have a traditional approach where we're aggregating multiple light fixtures into zones, right, rather than having individual zone control, and then controlling them with separate luminaires. Now, as I mentioned, I like to schedule these control stations. Here's an example of that. So this will give you all of the information that you would need to know to order the devices, to program them, and so forth, right? Catalog information about what it might be, a little bit about engraving, right? Engraving schedule for each one of them, and some of the notes, right, of what we might have in that space. Now, to take that into the sequence of operations, it might look something like this, right? We have room 101, we have zones A, B, C, and D. They're in the open office. They're all recessed troffers. My target light level is 25-foot candles. My lighting control station type is 1. I'm going to have manual switch in there. I'm going to have dimmer switch in there. I'm going to have it set up, this is a little tricky, from 7 p.m. to 7 a.m., the sensors are going to be occupancy sensors. From 7 a.m. to 7 p.m., they're going to be vacancy sensors. Why is that? I actually like vacancy sensors. I like occupancy sensors too, but the reality is during the daytime hours, a vacancy sensor works pretty well. At night, an occupancy sensor tends to work better. Why? Well, what happens if the lights trigger false off at night? right? You don't have any other light. You kind of stumble over to the switch and turn it on again. Whereas if it does false trigger off, which is relatively rare these days, you can then just kind of wave around and get it to turn back on. During the daytime, it doesn't much matter because you're likely to have other light sources in that space. Timeout information, what daylight dimming zone it is, the minimum daylight dimming percentage, task tuning. I'm going to task tune roughly down by 30% in this case in order to get to my target light level from my initial light level, right? And then I have these specialty notes that are here that will refer back to notes like this that are on my sheet, right? So I have things like normal business hours, some information about corridors and back of house toilet rooms, things like that. And I also have specific notes about how I want each one of the buttons in each one of those stations programmed. Now, this is a lot of information, right? But it's important to have. Otherwise, if whoever is programming this system doesn't have this information, what's going to happen? They're going to do their best, but they may not be able to get what the client or what the designer, what the architect, what the implementer, whomever, what you're really trying to get to. So it's really important to think about these sequence of operations. Okay, so this is network lighting controls. We talked about luminaire level lighting controls last week a bit, right? Remember, we said that with a luminaire level lighting control, you actually take all of the gear and you tie it into the light fixture, right? So you have a load controller, you have the driver, and you also have typically a smart sensor that is both daylight and occupancy sensor, right? So it all comes from the factory as one unit. Now, the benefit there is that you go ahead and put it up into the ceiling, into the wall, wherever it's going to go, and it basically requires 3 connection points, right? It requires a hot, a neutral, and a ground, and you're done. Everything else is programming at that point, right? So there are some significant savings from an installation standpoint and some really interesting gains from a flexibility standpoint, both from a design perspective, because you don't have to worry so much about what zones you're doing initially, and from a flexibility standpoint, right? It becomes really easy to individually address each one of these fixtures and change them on the fly as you need to, right? So how would we approach this differently? If you remember in the last example, we had 4 zones, right? 1, 2, 3, 4. In this case, we have 8 zones. Why? Because each one is individually controlled. They just go up in the ceiling, right? Now, you'll notice that in the open office and in the private office, we don't have any sensors on the ceiling because we don't need them. The sensors are actually within the light fixtures themselves, right? The control stations wind up looking basically the same because they are the same, right? And if you go into places like the team room and the conference room, you'll see we do still have these elements because not every light fixture is available with luminaire level lighting controls. Nor does it have to be, right? The real goal is to have most of the lighting, your kind of vanilla A-type lighting on all of the projects as luminaire level lighting control, and then you integrate the rest of it into the same system. This is the real benefit to modern lighting controls with respect to LLC, because there's nothing particularly new about this idea of putting sensors into light fixtures. I have a photograph from 1983 from a Keen Lightolier light fixture that had an integral photo sensor to it. The difference today is that A, they work really well, and B, that all integrates together. So you don't have to have multiple lighting control systems. You basically just have them talk to each other, right? These same sensors will talk to the sensors that are in the LLC fixtures. It all becomes one simple thing. So how does this work from a sequence of operations standpoint? Well, if we look at these sort of next to each other, they wind up being pretty similar, right? You start to see, I don't know why I have, so you'll see we have 8 control zones here, right? because that's what you've got. But everything else really pretty much works basically the same way, right? Now here's a different way again to annotate that if we were doing this with the floor-based zone control that we had before. And this is a zoom into it. This is a zoom into what these all look like, right? So this gives you sort of some sense of this. Okay. Does anybody have any questions about this? Because we're gonna leave this in a moment, and we're gonna talk about implementation. How do we make this stuff all work, right? There is one here. Is that one photocell able to control the secondary daylight zone? Walker, that's a good question. Let me advance to the next one. So if we assume that we have a daylight sensor here, Walker, in most cases, if we are talking about a networked lighting control system, yes, the sensor is actually looking for light level. It's doing that in one of two ways. It's either an open loop system where it's looking outside, or it's a closed loop system where it's looking down, or it might be a hybrid in which it's kind of doing both and working its magic that way. Now, what it's doing is sending a signal to the system, and the system is interpreting that, right? And it's saying, for the primary daylight zone, dim by this much. For the secondary daylight zone, dim by this much. Now, that's a networked lighting control sort of approach. If this was Luminaire Level lighting control approach, we would have a sensor in each one that would be a closed loop sensor looking down, and it would be essentially modifying the light output on a per fixture basis, right? So it's automatically becoming its own primary and secondary daylight zone. Now, all that said, you can do some advanced programming if you want to, and for some systems, and have the signal from each one of these sensors aggregated and averaged, right? From a Luminaire Level lighting control standpoint in both cases. Now, what that does for you, I'd mentioned that an open loop system looking to the sky tends to be less finicky than a closed loop looking down, because what I am looking at from a closed loop standpoint might be a whitish carpet, or it might the next day be changed to something that's very dark, and it's not likely to be reprogrammed, right? So if you are able to aggregate multiple inputs into sort of one average, that tends to make the closed loop kind of system much less finicky, much more apt to be accurate. I hope that all makes sense to everybody. And I'm not seeing any other questions here. So let me just give you a quick look here at implementation. So the things that we're going to be talking about, if we were actually in person, we would be programming these things into the lighting control demonstration boards that I've built. But you'll think of these when we talk about how some of these systems get programmed and some of the parts and pieces. We're going to assume that we have a zone one, so one primary daylight zone, one secondary daylight zone, one dimming zone in the office here, and two dimming zones here, right? And these are what the zones are. We'll have vacancy sensors, lighting control stations, and daylight sensors. Now, since there are no other questions here, I'm going to ask you the question. We're going to do another one of our fabulous pop quizzes. Why is it critical to provide a sequence of operations and specification? Your time to shine. Come on, folks, come on and let us know. Is it to maximize the benefits of lighting control system, to maximize energy savings, to simplify installation, setup, and commissioning, so that everyone can get off the job faster and move on, to reduce callbacks and problems for everyone? Do. do 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 do. All right, most of you have voted now, so we are going to close the poll, and I am going to share the results with you. Okay, so why is it critical to provide a sequence of operations? Of course, the number one there is to maximize the benefits of the lighting control system, right? Your owners are paying for a control system. We should really be making sure that we provide the energy and non-energy benefits that they're looking for, right? The flexibility, the productivity gains, all of these things. To maximize energy savings, absolutely. To simplify installation, setup, and commissioning is absolutely true. To reduce callbacks and problems for everyone is also absolutely true. And the one that nobody suggested here, so that everyone can get off the job faster and move on, actually is also true. If we have all of the information up front and we can distribute it appropriately initially, it saves everybody time and hassle, right? It's kind of one of those things where a couple of hours up front saves a lot of hours on the back end on a project. So please, 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 please document what the system is supposed to do, not just what the parts and pieces are. All right, I am going to hide that. If anybody has any questions, please go ahead. Otherwise, we are going to spend just a couple minutes talking about energy codes. Now, we're in Seattle, of course, so we have the Seattle Energy Code, we have the Washington State Energy Code, but if we are in a variety of different other locations, or if we're doing work in other locations, other codes might apply. The good news for us is that most energy codes that talk about lighting controls actually have some pretty common roots, right? Seattle, by the way, was one of the very first locations in the country to really take lighting controls seriously for energy codes. In fact, my recollection says that we were the first in the country to require daylight controls, for example. So that goes back a while, so my memory might be a little faulty, but if we were not the first, we were certainly among the first. So let's talk a little bit about energy controls in general, right? And what we're going to talk about really is true whether we're talking about codes like Seattle or Washington or Montana or Idaho that are based on the International Energy Conservation Code, or Title 24 in California, or Estidama in the Middle East, or SIBSI in England, whatever. They all have a bunch of commonalities. Now, it's going to be important for you on every single project to pay attention to the code because they change, right? So for example, in Seattle now, we require in offices, open plan offices that are over 5,000 square feet, network lighting control or luminaire level lighting control are now required, right? So that's an example of something that has just come in the last couple of years and really needs to be reviewed by the design team or the implementation team. But most of these codes come down to one basic element: turn the lights off when we don't need them to be on, right? Now, occupancy or vacancy sensors are required now in most project areas, right? Offices, break rooms, conference rooms, classrooms, corridors, stairwells. The number of places that you don't need an occupancy sensor or a vacancy sensor is lower than the number of places that you do now on most projects. Schedule, right? Scheduling events for when the lights need to be on or when they need to be off. Now, time of day scheduling is not nearly as important as it used to be, thanks to the ubiquity now of the sensors. But I did mention to you, for example, the one place that I really use scheduling is scheduling telling the occupancy sensors, you're an occupancy sensor during these hours, you're a vacancy sensor during these hours. But there are lots of places where we still do use time of day schedules to turn the lights on or turn the lights off, or to dim them, like for example, parking lots, right? So parking lots assume that if you're in a place that doesn't require lights to be dimmed down in a parking lot at night after certain hours, assume that you're going to be, right? This is coming if you're not already there. So there are places where we are going to use scheduling, and in particular, also remember astronomic scheduling, right? Based on sunrise and sunset times. Now, most spaces require manual control, right? You need to be able to turn the lights off. That's what the manual control requirement is for. So that, you know, even if you have an occupancy sensor that turns the lights on for you, in most cases, most rooms, you're going to need the ability to turn something off. Now, if you remember, we talked about dimming and the ubiquity of dimming the other day. And we also talked about the fact that the devices that are actually the wall stations, the cost of a wall station that has raise lower dimming versus the cost of a wall station that doesn't is more or less the same. So given that, go ahead and provide the capability of dimming, even if users aren't going to use it all the time. Give them that ability, right? It doesn't cost much more, if any more, depending on the system, but dim, make that happen. There's some specialty cases, in particular stairwells, corridors, and garages, right? Where corridors and stairwells, you need to be able to dim the lighting accordingly and have an occupancy sensor so that when you walk into, say, for example, a stairwell, the lights go up. Now, this also is nothing new. There have been light fixtures that have been marketed by the manufacturers for at least 20 years that have automated this process, right? They've been early Luminaire Level lighting controls where they would have the sensors in them so that when they sense people in the stairwell, they would dim up from their, say, 20% light output. I want to caution you. Please don't dim to off in these places. Dim down to, say, 20% light output, or in some cases 50% light output. The idea is you don't want to turn the lights off. You don't want people to go into dark spaces and feel scared, because then at that point, they're not going to like the lighting controls. They're going to figure out a way to disable the lighting controls. It's better to harvest, say, 80% of the power and then be able to dim up from that than it is to harvest 100% of the power for a month until somebody figures out how to disable the lighting control system. I hope that all makes sense. Daylighting. So some interesting things about daylight. The way that we talk about daylight zones, or the way that I wish we talked about daylight areas rather than zones, because it's a little bit confusing nomenclature. We used to think that daylight would cover larger areas than we kind of feel now. So the good news is that basically every code out there has these really handy diagrams that will tell you a variety of different space types and approaches to determining what kind of daylight requirements you have. So if you lack any other information, sort of from a window standpoint, assume that you're going to have a primary daylight zone that goes from the window over into the space to the head height of the window. What does that mean? If the window is 8 feet tall, the top of the window is 8 feet tall, your primary daylight zone is going to go in 8 feet from there, right? If you are in an area that requires secondary daylight zones, then you add another 8 feet as your secondary daylight zone. If it's 10 feet, then it's 10 and 10. I hope that kind of makes sense. And of course, there are modifiers that things like partitions and stuff like that. And here in Seattle, here in Washington, any place that IECC is, International Energy Conservation Code, holds sway. It is, in fact, of course, the primary and secondary daylight zones. Now, it gets a little bit more complicated when we start to talk about top light, right? Monitors, clear stories, skylights, things like that. But you'll see that in each one of the cases, right, there are very detailed descriptions of how to calculate the daylight area. Now, if you still have questions about that, feel free to call one of the code examiners in whatever jurisdiction you're using. Generally speaking, most of the codes folks would rather talk to you and talk through issues before they get a set of plans that they have to, because they don't want to have problems with you as well. So go ahead and spend some time talking to the code officials if you have questions. Another thing about codes, we used to use this whole idea of 24-hour circuits, right? And basically the idea was that you'd have what we might call stumble light or egress sliding on a 24-hour circuit. Here's an example. This is the Spokane Public Library, beautifully daylighted space. You'll notice that I'm standing at this window wall here. This was a fluorescent lighting system. Hopefully it's been upgraded since then. But you'll notice that there's basically one zone that is always on, in spite of the fact that the rest of these are dimmed down or switched off. Now, this is no longer allowed. Aside from the fact that it really doesn't look very good, it's not very useful, right? It's very easy to control, since we're talking about luminaires that are always dimmable now, right? We're not having to get specialty dimming ballasts for emergency systems. Most of the network lighting controls will have the ability to dim, right? And you'd be able to do this one of two ways. Now, the sort of very simple way is with what we call a shunt relay, right? A UL 924 shunt relay. So how does this work? Well, we've got an example here. This is a board that I've built to demonstrate this. This is the shunt relay. This is our this is a corridor. This is the emergency lighting. This is the primary lighting within that space. And then we have power coming in for an emergency feed to the device. That could be from an inverter, that could be from a generator, that could be from a constant hot emergency feed like they have at many campuses, right? And this is the normal feed coming in from the load center. Now we have a load controller, right? This is actually going ahead and providing that dimming signal, right, to the driver. The driver is in each one of these. So let's see this working. So I'm turning the corridor lighting on. I'm going to turn the corridor lighting off. You'll notice it all goes off together, right? Now I'm going to turn it on, and I'm going to show you that I can dim both of them together. Dim up, dim down if I want to. Now, if I lose normal power, you'll notice that the emergency goes to full light output. And when I restore the normal feed, the system senses that, and it brings the light back to the level it had been at before, and still allows me to go ahead and dim up, dim down. Now that's one way to do it. Some of the manufacturers, somebody had asked the question yesterday, why the red load controller here. This particular load controller is designated as a UL 924 emergency device. So it senses when it's going to lose normal power. So let's see how that might work. So again, this is the demonstration board I showed you. I've just turned on all the lights. I'm dimming all the lights, so I have complete control there. Now, I'm going to turn off the power to it for a second. This is not quite as obvious as the other demonstration, apologies. But you'll notice that when the power is restored, that zone, the emergency zone, is at full brightness, not the dimmed level, and you can't turn it off for a certain period of time. This kind of emulates the idea, again, apologies that I don't have this set up with a different feed, but it will give you the sense that of how these things work, that you have to have the ability when the normal power goes away to drive the load to full, and depending on how the system is set up, keep it there for a certain period of time. I hope that all makes sense to everybody. But there are ways to do it. It used to be very expensive. You had to use UL 1008 contactors and all kinds of groovy stuff, but it's really not anymore. Okay, let me go past that. All right, and exterior lighting, right? I'd mentioned exterior lighting is becoming more complicated from a control standpoint. Depending on where you happen to be, you're certainly going to have scheduling, right? You're going to have to either turn the lights off at certain times or dim them down at certain times. And you might have things like migratory bird patterns that you have to take into account, dimming exterior. Exterior occupancy sensor is another one. Occupancy sensor control is coming, right? So you'll have parking lots, for example, that will have occupancy sensors on the poles. Now, again, we're not going to want to dim down to 0 because we don't want a dark, scary space, but we are going to want to harvest most of that lighting. Another code thing is controlled receptacles, right? So 50% of all outlets have to be controlled. Now, there's been a lot of complaining about this because, oh my goodness, I plugged my CPU in. They have to be annotated. Don't plug your CPU into a controlled outlet and you'll be fine. But it does really help with turning off the vampire loads, right? The platen on your printer, the monitor, all those different things. So, give you a quick example. I'll just turn the lights on. Now you'll see here that the task light that is in the controlled receptacle is going on and off with the switch here. Now that could be the switch, that could be an occupancy sensor. This is one way to do it, which is this is a smart receptacle that actually has a radio frequency controller in it. It's taking a signal from the lighting control system, the communications hub, and it's going on and off according to that. Or it could also be a load controller very similar to this. This is a 1 amp or 3 amp load controller, but you can get 20 amp load controllers as well. So you can get system load controllers that will just turn on and turn off based on the system as well. So some manufacturers offer these kind of smart receptacles themselves. Some manufacturers control the circuits based on a 20 amp load controller. Either way, it's not terribly difficult. Another thing that you are going to want to pay attention to is commissioning. Right? We in the industry talk about commissioning, and we're a little bit lax in our terminology because we talk about commissioning a lighting control system when what we really mean is setting up a lighting control system, programming it. Now, third-party commissioning has been the fact for HVAC systems for decades, right? You have to test, you have to make sure that the systems are working the way they expect them to be. Now we're doing this for lighting and lighting controls as well. So we're not going to go through this right now, but if you go to the IES Illuminating Engineering Society document here, DG 2911, there's a fantastic, very clear flowchart of all of the steps in order to get your lighting and your lighting control systems commissioned, right? And assume that you're going to be working with third-party commissioning agents. Now, we've talked about LLC, right? Luminaire Level lighting controls and some of the benefits of those. Easy to install, easy to design. It's also an easy code compliance pathway. A lot of energy codes allow you to, instead of detailing all of your lighting controls in various areas, if you have LLC luminaires, it's a checkbox, right? Rather than having to fill out laborious spreadsheets, it's there, it's right. You already have all of that kind of information. Now, if you want to learn more about LLCs than I can tell you in this sort of brief class, go to our resources page. We've got videos about LLCs. We've got learning guides that are general, but then also specific to certain project typologies like schools or like hospitals, healthcare, things like that. A variety of different things there. And it's important to understand that there are also, in particular, a lot of potential incentive benefits from a variety of different electric utilities for projects if you are doing particularly retrofit projects, right? If you're using LLCs, for example, on a project, City of Seattle, Seattle City Light, and Puget Sound Energy will both incent up to $75 per light fixture if you are using LLC. What does that mean? It means basically the cost of the lighting controls becomes free. So please consider that when you do that. If you have more questions about that, ping us at lightingdesignlab.com and we will try to connect you up with the appropriate resources to give you more information about those very, very cool programs. Okay. One of the most overlooked elements of commissioning, and it's truly commissioning, is the idea of commissioning the occupants, right? Tell the people in your spaces what to expect. I can tell you a very long story about a very big problem on a project of mine years and years ago, where people were disconnecting the lighting control system or overriding the lighting control system because they didn't know why the lights were turning off, right? And it was a daylight control system. So tell the occupants what to expect, let them know how to interact with the lighting controls. And that's usually just a little cheat sheet. Here's the lighting controls, here's what you're gonna do. And most of the time, the people will actually be happy about it. Okay. Let's move forward unless there are any questions, and I'm not seeing any questions. So I'm gonna give you a quick case study. This is my own office. Used to be my office when I ran Luma Lighting for PAE engineers. So we did a tenant improvement in the Bullitt Center up on Capitol Hill. This was my office up here on the 6th floor. We expanded, we moved down to take over the entirety of the 3rd floor. Our renovation was about 6,100 square feet. It was completed in 2017. Now, the lighting design was pretty high performance, right? It was all LED, of course. There was some decorative. We had on this floor plate about a power density of 0.55 watts per square foot, which is good, but not stellar. But that's because I was intentionally planning to task tune down in order to extend the lamp life of most of the lighting controls gear, right? So the basic lighting power density of 0.55, and we had all of these control strategies designed into the system. Well, this is a cautionary tale. I went on my honeymoon about the time that this project was being implemented, right? So the light fixtures were installed, but the controls hadn't been. So while I was gone on my honeymoon, the controls were what? Value engineered. Value engineered. So essentially they were cheapened, saved a couple $1,000s, big deal. And the controls were supposed to meet energy code. They kind of didn't really, but we still got a certificate of occupancy in the cheapest way possible. And frankly, it was impossible to control the lighting, right? So we're a high performance MEP and lighting firm, mechanical, electrical, plumbing design firm and lighting. And it wasn't possible in one of the best daylighted buildings around to be able to turn the lights off. Every time we turn the lights off, it was some kind of bizarre emergency sort of system that would turn these lights on and the corresponding ones over in the other side. So it was literally not possible to turn the lights off. Now, this is a building that is used as a demonstration facility for people worldwide on high performance buildings. So Dennis Hayes, one of the people who can claim to have invented Earth Day, is the Bullitt Center or the Bullitt Foundation chairman. He would come down leading a group of tour people, and he'd look at my desk and he'd say, "Why are those lights on?" And I'd say, "Well, because the VE was accepted," right? So this went on for about a year until we were approached. One of my colleagues helped work this out, Michael Kim. We were approached by Lutron about potentially being a beta test site for their new Luminaire Level lighting control system, right? It was a parts and pieces system that was then networked together into what is now called Vive. Now I want to be clear, we work with 8 different manufacturers in this class. Any one of them could have done this just as effectively. So this is not a plug for Lutron, this is a plug for networked lighting controls. So what we did was essentially completely retooled the lighting controls here. We added load controllers per each light fixture. so that they were effectively Luminaire level lighting control. Everything was individually addressed. We didn't have the sensors in the fixture, so technically it wasn't Luminaire level lighting control. We added wireless occupancy sensors, wireless daylight sensors, and wireless switches throughout the space, and a communication hub. So we started then to be able to do things like effective daylight harvesting. We were able to task tune down to the light level that I initially wanted. Scheduling, all of these things. The best part about this was that we could actually turn the lights off. So in our conference room, we could turn the lights off when we wanted to have a conference without the lights because we had tons of daylight within that space. Made staff ecstatic to be able to actually go ahead and control the lights the way they wanted to control the lights, right? Now, what this ultimately meant was that we task tuned by more than 25%, again, fully functional daylighting. Vacancy sensing was contiguous by row. So you can see here, Mitria is down here on a Sunday when I'm taking this photograph, working on something, I don't know what she was working on. And the lights are on only for her. Tony also, the lights are on only for him here and one other row that you can't see. Previous to redoing this, if people were in here working, all of the lights had to be on at full all the time. So hugely, hugely effective. We had more than 70% energy savings, right? Right now, the effective lighting power density is about 0.15 watts per square foot. Now, this is an outlier, right? Because it's such a beautifully daylighted building and it's populated with people who actually are paying attention to the lighting controls and energy use. So more common sort of energy savings for these things tend to be in the 45 to 55% range, but this shows you what's possible. Now, from a costing standpoint, this is a retail cost. I went ahead and found every piece that we used on the project and took a retail cost, what it would cost me to buy it from Amazon, right? And it came out to be about 78 cents per square foot to get this high level control. It used to require $4 to $5 per square foot to get this kind of control. Now, 78 cents per square foot, again, that is retail, right? If we were talking about this on a project cost basis, we'd probably be closer to more like 50 cents a square foot. I hope this gives people a sense of what's possible, also what is out there with respect to the abilities of these systems as well as the effectiveness. Let me give you another quick pop quiz because it's important to keep you guys with me. What are the code implications of using Luminaire level lighting controls? And if you have questions, please go ahead and pop them into the chat, into the questions box now. But for the moment, is it simplified energy code documentation? Is it guaranteed to meet code? Is it simplified installation and setup? Is it many utilities offer rebates? Is it they offer some functionality out of the box? What are the code implications of using LLC? Do, 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 do. Come on, folks, we'll give a couple more seconds here. Let folks vote. 2 more seconds. There we go. All right, so I am going to close this poll and here are the results. So what are the code implications of using LLC? Simplified energy code documentation. That's the primary one. It really saves a lot of time documenting energy controls. Now, it's also guaranteed to meet code. It basically is guaranteed to meet code because you can do everything that any code that I've ever encountered requires if you have an LLC system. Now, the other 3 are absolutely correct, right? They are true. It does simplify installation and setup. Many utilities do offer significant rebates for LLC systems, and they do offer some functionality out of the box, even if they aren't properly programmed. But from a code implication standpoint, the first 2 are the key ones. All right, so let's go ahead and hide this. And let's talk a little bit about the systems themselves now. So we've gone ahead and talked a little bit about the homework, a little bit about how to put a system together from a sequence of operations or what is it supposed to do kind of standpoint. We've talked a little bit about some of the code requirements. We've given you a case study of how some of these things were sort of put together in the real world. Let's talk about the systems themselves. In this particular class, we work, when we're doing a hands-on version of this, we work with a number of different manufacturers who all have systems that have significant differences, but also significant commonalities, right? So they're all great systems. They all work really well. They have different strengths and I don't want to say weaknesses. Let's just say they have different strengths, each one of the particular ones. So they're all capable of doing everything that I just said on the bullet center, and most of them are programmable via apps on your smartphone, right? We use in the classes, actually use an iPad to teach people how to program these. So let's look at the parts and pieces of some of them. Now, this is not exhaustive, but the dominant parts and pieces. So Acuity Nlight Air has luminaires, and this is predominantly based around Luminaire Level lighting control. Not exclusively, you can get parts and pieces, but the predominant use is LLC. So you've got devices, you've got wall stations, you've got a programming app that all communicate with each other. This also communicates to the cloud, so there's some cloud information there. So pretty simple set of parts and pieces. Odyssey, another company, Odyssey by Ideal, has a communications hub that ties everything together. And then they have load controllers, occupancy, vacancy sensors, daylight sensors, and switches, right? So parts and pieces approach. Wavelengths by Cooper has communication hubs and load controllers, or integrated load controllers within the light fixtures themselves for LLC, and scene stations and receptacles, all programmed by an app. Cree, a little bit different, again, basically focuses on Luminaire Level lighting controls, and they wind up using a programmer rather than a smart app. But the same kind of thing, parts and pieces, switches, load controllers, Crestron Zoom, switches, sensors, load controllers programmed by apps, Encelium Edge, communication hub with load controllers and sensors and switches programmed by an app, ETC EchoFlex, Lutron Vive. What you'll notice in all of these is that they're all more or less the same. And I don't mean it to say that they're equivalent, because there are differences between them, and you do need to pay attention, but they're trying to do the same thing. So there's only so many ways that you can approach the same outcome with the physical gear that we're talking about in the built environment, right? So the good news is that there are a lot of options out there from a specifications standpoint. So you can go ahead and specify a number of different manufacturers that are all going to be able to work together, so you can set up competitive bidding, which is great. Now, they really tend to be, from a physical standpoint, very similar, right? So where some of the divergence comes are in some of the very specifics. How does the communications occur? How does the programming occur? So let's talk about some of those. Some systems require communication hubs, right? So Lutron, Cooper Wavelengths, Ideal Odyssey, Encelium, they'll essentially be a device that communicates to the fixture load controllers, to the sensors, to the wall switches. Usually these days that's wireless, although in most cases, if you really want a wired system, you can get a wired system and they'll still work. But it's much cheaper, much easier to go ahead and do this wirelessly. So in this particular case, these communication hubs, and they'll call them different things, network hub or gateway or whatever you want. You'll have essentially one of those serving a specific area, right? So 10,000 square feet, 20,000 square feet, whatever it happens to be. Very similar to the way you would set up a Wi-Fi hub or a Wi-Fi router. And they communicate with a variety of different protocols, right? Bluetooth or Zigbee or Wi-Fi or some other proprietary protocol. Now, some systems don't require this. Some systems will communicate either through a LAN to the cloud somewhere, or they'll actually, the smarts will talk to each other, the devices will talk to each other in more of a mesh configuration so that you don't really require this. But either way, they'll all have load controllers of some kind, right? Either the load controllers will live within the light fixture itself, as in the case, for example, of the Cooper wavelengths that I was showing you, right? There'll be a small load controller in the light fixture that then connects up to the LLC sensor. Or you can have these other options, and they'll communicate in a variety of different ways, right? So they'll be available for, remember we talked about communication protocols, 0 to 10 volt, or in some cases Dolly, DMX 512. They may have 2 wire or 3 wires connecting to them depending on what protocol you're using. And they'll either be for dimming for lighting or switching for lighting, or they might be for larger like 20 amp devices for plug loads. Right? Some of them might be UL924 devices. Then we have LLC light fixtures, of course, where basically everything is in the fixture itself rather than having the complete parts and pieces. You're still going to have switches and all those other devices, but these all come together. Then, of course, every system is going to have a variety of switches and dimmers. Now, again, for most manufacturers, the difference in cost between an on-off switch versus an on-off switch with raise lower for dimming or versus a 5-button preset station, whatever they happen to be, the differences in cost are minimal in most cases. So spend time thinking about whether you want to have dimming control or preset control rather than worrying about whether it's going to be more costly as we used to do. And of course, everyone's going to have occupancy or vacancy sensors. They may be integrated into the light fixtures, like this unit here would be integrated into a light fixture, or they may wind up being separate. Now, of course, again, we talked about the differences between wired and wireless sensors the other day. If we have a passive infrared occupancy vacancy sensor, that can be battery powered. If it's ultrasonic or active in some way, it's going to actually require wire, right? You're going to have something wired. Now, I will also say that when you have something that is LLC, the sensor itself tends to be hardwired into the fixture, but the system as an aggregate communicates most of the time wirelessly with the larger system. I hope that makes sense. You, of course, have daylight sensors in the same way. They can be open loop or closed loop or a combination. And most of the time these days, these can be battery powered. Again, you can get them wired if you want to, but that just adds cost and complexity to the system these days. These again are the integrated sensors. Now there are some other aspects to some systems, right? So we're talking about lighting. We think of daylight, occupancy, and vacancy sensor, but some systems actually have other sense capabilities, right? What's the temperature, the humidity, the carbon dioxide in the room? And that's so that the sensors can integrate more fully into smart building systems so that they can provide more information rather than having to have multiple networks of sensors. Let's unify them, right? Let's put them together. Plug load controllers as well. And we're going to go to another pop quiz. This is going to be a quick one. Do all networked lighting control systems Oh, you know what? I don't even have this one here, so I'm going to skip it. Do all network lighting control systems require communication hubs? The answer is no. Some do, some don't, but we'll move forward from that. Sorry, I don't have a poll set up for that, oddly enough. So again, these are the demonstration boards. When we teach this class in person for the full day or the 2-day, preferably, classes, we actually program all of the sequence of operations that we've been talking about into these devices. So we have the load controllers, right? 5 different load controllers here. We have a communications hub that is not shown here. We have the switches that would go on the walls. We aren't seeing the specific occupancy or daylight sensors here, except for these guys, which are hardwire occupancy daylight sensors that can be sort of luminaire level controls, right? So this will give you some sense of how these things all come together. So what about programming? If we get all of this gear together, right, we've got so much commonality, some of the programming really starts to diverge a little bit, right? The parts and pieces can do more or less the same things. How they do it varies a little, but most of the time, not all manufacturers, most of the time we're talking about using programming apps, again, that are set up for smartphones, smart tablets, things like this. Some manufacturers offer extended functionality if you are using a computer, but most of the time you can do it all via an app, which actually makes it pretty simple. Now, I will say that the app-based programming is really applicable for mid-level projects, right? Up to say 100,000 square feet. Once you get much bigger than that, you might want to start looking at the big brother of each of these systems, because they all have a big brother that can all be programmed via computer, simply because then you can copy and paste spaces much more effectively. So if we're programming, how do we start this? The first step is we actually establish communications between all the devices, right? If we were in person, we would go ahead and power up the hubs and make sure that the systems were talking to each other, all the devices. And then there are a number of common things that we would wind up doing. The order might be a little bit different depending on the system, but effectively, the first thing to do is to discover devices, right? So how do we start to figure out what kinds of devices and how many of each are within the system range, right? The load controllers, the wall switches, the occupancy sensors, the daylight sensors. Some systems will automatically find them, in which case then you need to just figure out which component is which. Some you have a little bit more upfront work to do. So I like to start also with the notion of, actually, let me go back to that for a second. I may talk about this a little bit later, but I may not have noted it in this particular deck. Some systems will actually require you to have things like QR codes that you scan with your app. Basically, you would get a load controller when you're installing it. You put the load controller in the ceiling, you put a QR code sticker onto the plans where you've installed that, and you then go ahead and have the ability to know what you're scanning. Some systems will, you press a button and it will take a few minutes, it will ping, it will query, it will automatically determine what systems are in the specific area. And then at that point, you would need to do what we call blink them or flash them in order to determine this device that I see here, I'm gonna blink it, it's gonna blink on and off. Okay, that's the load controller for this zone. This is the load controller for that zone. I used to think that the automatic device discovery would be tremendously simplified, but the reality is it takes about the same time, whether you're doing the flash method and having to do the automatic device discovery, or whether you're doing this sort of QR code method. They're pretty similar in the amount of time that they take. Okay. So I like to also add in project information. You can do this in basically every control system, right? What's the name, the location, the latitude and longitude? Why do I want that? I want those so that if I'm using not occupancy sensing, sorry, astronomic time scheduling, I've already got that information in there. Then I also add in the fact that I'm the designer or engineer or whatever. And that's because 5 years, 10 years, 12 years from now, when a facilities person is trying to figure out why we made a choice, I want them to be able to contact me directly and ask me, because I'm probably going to be able to answer the question pretty quickly rather than having some poor facilities person struggling to figure something out from a set of plans that they may or may not have, right, with the specifications that they may or may not have. So some other things that we commonly do, right, we set up areas, rooms on the projects. So we will define all of the subspaces, right? In this particular case, this is an interesting one in which we have in one particular area, there are several subspaces, right? This is the REI flagship store in Denver, Colorado. There are several different areas here, right? There is an area here for retail. There's an area on the other side of the climbing wall for retail, but the climbing wall itself is completely separate. So even though they're contiguous, from a control standpoint, this is one control area, there's another control area, the climbing wall itself is a control area. Basically, think of this as spaces where you want scenes to function differently, right? So in most cases, it's just going to be individual rooms. Then you go ahead and set up your control zones, right? This is from the project over in WSU that we were looking at, Zone 1-27, Zone 1-28, and take the time to fill them out, right? Note what the type is, what the Luminaire type is, add as much information as you can, because this is how it's going to be maintained over time. The more information that is in the system up front, the better it's going to be for everyone long term. Then your plug zone controllers, switches and dimmers. Add in your switches and dimmers to the systems, right? And name them if necessary. Most systems, even the QR code ones, will automatically determine what kind of switch or dimmer it happens to be. So the things that you're going to need to program to it are what zones are active to it, what scenes are active to it, what the dimming levels are, all those kinds of things. Occupancy sensor and vacancy sensor, right? Is it an occupancy or a vacancy sensor? Again, in most systems, it's an electronic switch, right? You decide whether it's one or the other in the programming, and you can change that on a time basis, right? What is the timeout? What is the sensitivity? Daylight harvesting. How do you add these to the systems and setting them up? Most of the time with most systems, you're going to need to set these things up with an actual light meter so that you're actually determining what light level they are supposed to dim to. Then you're going to need to pair all of the devices. What does that mean? Basically, all of the load controllers, all of the control zones, and in this case, load controller and control zone are basically the same. They're synonymous. You have to decide which switches, which dimmers, which groups, which scenes, presets are going to be associated with each one of the switches or dimmers. What's going to happen when you touch a button effectively. And also the vacancy sensors and daylight sensors. So for example, as I've mentioned, we've got these configured in pairs. So if we've got an occupancy sensor here, this occupancy sensor is speaking to this fixture and this fixture. This occupancy sensor, and I'm not pointing at an actual occupancy sensor, but I'm showing you the idea. If we had an occupancy sensor here, it would be speaking to this fixture and this fixture, right? And so forth. Same with plug loads. We're going to want to set levels for the scenes, right, in the individual scenes that we have within spaces. And then we're also going to want to look at task tuning. Again, remember, I saved 25% at the bullet center intentionally. So this is one of the places that is so frequently overlooked. We really, really, really want to remember that we want task tuning on projects, right? The other important thing about task tuning to remember is it costs you nothing, right? There is no additional cost for this. It just means that you have to program what we call a high trim. So you just program dim the control zone down so that it matches the target light level that the designer is looking for. Add in any of the scheduling events that you might have. And then also spend a little bit of time thinking about the notion of demand response load shed. Now, we talked about this the other day. Load shed demand response is basically that idea that on a large area, if you dim the lighting down by a certain amount, when the electric utility is either going to be having potentially a brownout, for example, if there's not enough power, or if we want to save a little bit of energy from a time of day standpoint. Remember, electricity on the wholesale market can fluctuate widely from a cost standpoint. Imagine that this is going to be coming to your homes at some point as well, because as we electrify more and more, we get better with smart meters, we get electric cars and all of these things. We are going to want to modulate when things like cars are charging, right? Do we want them to be charging at the very peak, very most expensive electricity time, say 6 to 9 p.m. at night or whatever that happens to be? Probably not. Do we want them to be charging at the relatively inexpensive times, 4 o'clock, 5 o'clock, 3 o'clock in the morning? Probably so. So this becomes this kind of idea of demand response. Okay. And another pop quiz. And also Walker has a good question. I will ask the pop quiz and then I will answer Walker's question in a moment. What are the steps we might take in task tuning or high trim setting? So, is it providing a target light level documentation in the sequence of operations, taking on-site light level measurements with a light meter, finding target light level documentation in plans or specs, guessing what it looks like to you and setting the dim level, or leave it to someone else? Please populate in your responses there. And while you're doing that, Walker asks the question, do you use the term task tuning in the same sense as high-end trim? And the answer is yes, Walker. So the terms, one of the problems or issues with the lighting control industry is that we have a lot of different vocabulary for the same things. Task tuning is an older version or a different version. The idea is that you set a light level based on the types of tasks that you're going to be doing. And that basically means you would most commonly dim the lighting down to where that level happens to be. And then you would set what we call a high trim, right? That basically as high as the control zone will be able to go. So that's kind of how that works. So that yes, they are basically being a little simplistic, but they are basically the same thing. All right, so let me go ahead and close this poll and share the responses with you. So what are the steps we might take in task tuning high trim? Providing the target light level documentation in the sequence of operations is absolutely critical. We want to know what the design light level is. On-site light level measurements, absolutely. That's how we wind up targeting it in. Now, I gave you a shorthand when I talked about the sequence of operations in your homework, and that's only because it's a hypothetical. So I had a certain initial light level, right, which was higher than my target light level, and I just did a quick bit of algebra and said if I dim it by 30%, it'll get me to that target light level. Now, it's a little more complicated than that in real life. In real life, what we would do is go out there with a light meter, find a location that we want to be the target, right? And then we would dim the system until we got to that light level, right? And then we would check our work and make sure that it was true. If we were in a space that had a lot of iterative kind of spaces, like for example, a healthcare clinic where we had 30 exam rooms that were all the same, we would basically do that once with the light meter and then replicate it in all the other places and then just go and check it, right? We would certainly want to find the target light level documentation in the plans and the bottom two, guessing what looks good to you is never really a good option. And leaving it to someone else is frankly what happens far too frequently, but it's also not a good option. Okay, let's hide that. And let us go into, I have just thrown, again, just like last week, a boatload of information at you really fast. This is your first opportunity, oh, it's not your first. This is a major opportunity to ask any other questions. Today, yesterday, fundamental concepts, reasons that we use controls, strategies, dimming 101, problems that you've had with controls in the past, parts and pieces for networked or Luminaire level lighting controls, anything that might seem a little bit unclear to you at the moment. Anything at all. All right, we're going to switch gears then for the remaining time that we have, and we're going to talk a little bit about the future. So we've talked a lot about where networked lighting controls is now, and this is hopefully an opportunity to give you a sense of what's coming down the pike and how we integrate now into the bigger smart building ecosystem, right, in a lot of cases. So I will caution you, I'll tell you first off that if my oracular skills were better, I probably wouldn't have sold my Apple stock in the early 90s. So take that as written, right? I will give you my best guess, but none of us have the crystal ball here, right? So one of the most important things about networked lighting controls today are the letters I, O, and T, Internet of Things, right? Hopefully everybody here will have interacted somehow with the whole idea of Internet of Things, where we're talking about the idea that everyday items can't be everyday items anymore. They all have to communicate with each other, right? And it makes sense in some ways, right? HVAC systems, room scheduling, communications. It makes sense to integrate things together. So one example that I could give you from actually a number of years ago, 2012 is when we finished it. We talked about that San Francisco Public Utilities Headquarters project. In that particular case, we actually developed a specification for systems integration so that the HVAC system and the scheduling system and the alarm system and the fire alarm system and the security system could all take inputs from the network of occupancy vacancy sensors that we installed for lighting controls, right? So for example, in something like that, you might have a scheduling system that's scheduling conference rooms. We all know that conference rooms, we have more than we need, right? Or we did pre-COVID anyway. So if a conference room got scheduled, say from noon to 1, and the occupancy sensor hadn't fired by say 12:15, the schedule could be deleted, it could be canceled, and that could go into the general pool of spaces that were available again, right? So there's a real estate efficiency there. From a security standpoint, right, what happens if there's an active shooter situation? Well, security can tell using my occupancy sensors which rooms have people in them, right? There's a value there. Now, there are bigger implications with this whole idea of Internet of Things and integration, right? My in-laws have a smart refrigerator. It's not hooked up to the internet, but it certainly could be. There's a great meme going around Facebook a while ago that showed a stainless steel toaster, right? And it was spun around so that you couldn't see the plunger controls, and it had a little sticker on it that basically said voice activated, talk to it. So the idea was you'd put your toast in and you'd tell it, of course it's a gag, right? You'd tell it to toast. But I was at a conference not too long ago, a few years ago, where somebody was talking about this idea of integration and MEMS, microelectronic mechanical sensors, right? So the example that they had was that you would have a water bottle, right? And the water bottle would have a sensor in the water bottle that would then communicate with your smartphone that would tell you what the temperature of the water bottle was. Or you could, I suppose, do this in your cup. So I have a cup of tea here. So I could have a sensor in here to tell me how hot the tea was. Now, interestingly enough, I may be a Luddite, but I have a sensory system that can do that. After 2 hours, the tea is lukewarm. So whether this is useful or not is going to be in sort of the eye of the beholder to a certain extent, but it's a big deal, right? So this is a couple years ago now, 2017, where Target started to do IoT with half its stores with one of the major lighting retailers, right, with Acuity. Now, this sort of thing has been doing nothing but gaining steam, even though we're in COVID. So in this particular case, how do you deal with the Internet of Things with lighting in Target? Well, think about this from a lighting control standpoint, right? Lighting fixtures live in the ceiling. Lighting controls live in the ceiling. What can see the entirety of any given space? Well, the ceiling. So you've already got devices that are in the ceiling. They already occupy real estate. You're already having to pay for them. And they're already powered. And they probably have some level of data communication, right? So they make that the perfect platform for creating this network of Internet of Things, right? Whether it's simply a communications network or it's things like hot tracking. So imagine, you are hot tracking people through Target, most commonly by Bluetooth, right? So every single one of us has a Bluetooth device here, right? Some of us carry 2 of them with us on various places. Now, normally speaking, they're not tracking you or they're not tracking me as Shaun Darragh unless I have registered, with the company as a user. Then they can certainly track Shaun Darragh. They can know that I spent 5 minutes in front of this single display and I did this and I purchased or didn't purchase. So there are a lot of different things that they can follow, right? They can follow you through the store. They can follow you in a lot of different places. So let me give you another pop quiz. Oops, come on. How many of you find this a bit creepy? Yes, no. Is anyone tracking this? Is anyone tracking this particular poll? Do you find it creepy? The whole using lighting controls as the platform for so much of what is going to happen. All right, I'm gonna close this and I'm gonna share it. Because to a certain extent, this is kind of a facetious poll. So 67% find it creepy, 38% find it not creepy. When I do this class in person and I ask this kind of question, there are some usually interesting breakdowns, and they tend to be that those of us who are a little bit older tend to find this a little bit more creepy. People who are a little bit younger tend to find it a little bit less creepy just because they're kind of used to it. But those are not etched in stone divisions, by the way. It's not always that way. But I will say that while there are some issues, frankly, you're always walking around with a device that can track you. Whether we like it or not in the modern world. If we've got a cell phone, we can be tracked. So if you really want to have a little bit less scary on this, get yourself a copy of the book Big Data. Big Data will hopefully assuage your fears a little bit, because with the amount of information that's being captured all the time, it's really hard, not impossible, but it's hard to drill down to specific individuals. Even if you're a Facebook user, if you look at the supposedly tremendous algorithms that Facebook has to to target ads to you, if you're like me, you'll find that their algorithm is laughably off target with respect to the things that I might be interested in. So that actually gives me a little bit of hope. But let me think about some other things here, right? So there are some creepy aspects here, but what about some of the positive aspects, right? If we've got this whole idea of a networked lighting control system that is forming the basis of this whole array, if I want to be tracked, what about in the healthcare environment, right? So if I'm in the hospital and I'm there to get my left kidney out, I want to be tracked accurately from the time I get into the first wheelchair at the door. I want to be tracked accurately to my room, to the gurney, to anesthesia, to the operatory, to the recovery room. I want each one of those spaces to know who I am, what I'm there for, and why, right? Of course, I'm probably going to still use an analog technique of making sure that they take out my left kidney instead of my right kidney. I'm going to take a big old Sharpie and I'm going to go ahead and write, take out this one, please leave this one. But it still gives the ability to track patients and to tie records to patients and hopefully minimize some of the potential for mistakes. Let's face it, the problem's even worse today, but at the best of times, healthcare workers are understaffed and overstressed, right? Today with COVID, it's even worse. So anything that we can do to make their lives easier, that's great. Now, another key aspect of this isn't just tracking people. Right? One of the things that I used to do a fair amount of healthcare lighting, and when this sort of stuff first came up, I talked to some staff about these kinds of things. And one of the things that they told me was that there are specific items, particularly in trauma wards, trauma centers, that it really makes their lives much easier if they can track them easily. Like, for example, a crash cart, right? So crash cart, what does that mean? That's a cart that has probably a defibrillator on it, probably a variety of different drugs that are used in order to stimulate the heart, right? So adrenaline, basically, if you're crashing, if your heart has ceased, that this is the kind of thing that they're looking for to try to get the rhythm back in your heart. So seconds count, right? If they have to try to figure out, is the crash cart in exam 1, 3, or 5, seconds are wasted. If they can glance at a dashboard up on the wall and say, oh, it's in exam 1, they can grab it and go, right? So there are some benefits there. So what are some of the other things that we might see with respect to the future of lighting controls? In some respects, the future is here, right? So we have color tuning. Now, luminaire manufacturers, I told a class 4 years ago at Powerful Business that I figured that within 3 to 5 years, most of the luminaires that were out there for sort of vanilla A type, recessed downlights, things like that, would be color tunable, because it makes it easy for manufacturers to have one SKU on their shelves to manufacture, stock, sell, ship, than to have a recessed troffer at 2700 Kelvin, 3000 Kelvin, 3500 Kelvin, 4000 Kelvin, and so on, right? Makes it very easy. I think COVID has pushed that back a little bit, that timeline, but the reality is that's still what's coming, right? A lot of fixtures that are available out there now have field tunable light output, as well as field tunable in terms of amount of light, as well as field tunable color temperature. So the whole notion of using color tuning, either for what we prefer, right? I actually At my sister's house in New Hampshire, a house that I built with my dad years and years ago, there were T12 Circline fluorescent lamps in a couple of rooms that had been put in probably 1974. Right? They're still there. They're still operating. I couldn't allow this to happen. So when I was visiting, I went to Home Depot, spent $60 on 2 light fixtures, and those 2 light fixtures, relatively inexpensive things, offered the ability to do 2700, 3000, or 3500 Kelvin field selectable with a dip switch. This is coming. The higher end fixtures that you're going to find, they're going to be selectable with lighting controls, right? So rather than dip switches in most cases. But having this ability to color tune classes, schools are already doing this in some cases. Renton School District is a great example. Talk to those guys if you want to have some more information. But the idea is, whether it's physiologically correct or not, the idea is that bluer light makes people more alert, redder light makes people, or warmer light makes people sort of calmer, right? So they're using this intentionally. If we go ahead and add a time of day controller to it, we might call this circadian lighting, right? So the idea is, for example, in an office or in a healthcare environment, bluer light in the morning, warmer light at night stimulates better attentiveness during the day and better sleep at night. Now, I'm wildly simplifying this, and I'm going to keep wildly simplifying it, tell you that there are basically 6 key variables, sorry, that most of the researchers into the photobiology are telling us are important, right? The intensity of the light. So how much light is there? The distribution of the light. Where is the light coming from? Is it coming from above? Is it coming from below? Is it coming from the sides? The spectral power distribution, that's a fancy way of saying, is the light more blue? Is the light less blue, right? What is what part of the spectrum, from ultraviolet to infrared, is represented within that light beam? The duration, how long are you being subjected to the light? What time are you being subjected to the light? And the photobiological history, meaning how many days in a row, for example, have you been subjected to this kind of regimen? The fact is that most of these stimulus variables are controllable by lighting controls. So the jury is out to a certain extent of whether intensity is more important than the spectral power, is more important than the timing or the duration. There's still research going on. But the fact of the matter is, you can use lighting controls to modulate almost all of these, except for distribution and history. Everything else you can actually modulate with a networked lighting control system. So this is going to be another one of these key non-energy benefits that is something that is going to convince people to use these kinds of networked lighting controls, right? Now, another one is Li-Fi. Again, this has kind of been stalled a little bit by COVID, but essentially you use pulsing light in order to communicate. A good way to think about this is most of the communication that we are engaged in right now is being communicated by light across fiber, right? So pulsing light that is being interpreted by a multiplexer and a deplexer at either end. Well, imagine instead of having a piece of fiber, that's pulsing, you have pulsing coming from the ceiling from the light fixtures that is pulsing either with infrared or potentially with visible light faster than you can potentially see, and you've got a receiver on your computer. That's an extremely fast way to increase bandwidth. It's also a good way to increase security, right? Wi-Fi signals are hard to contain unless you're putting them in a metal box. Light is relatively easy to contain, which is why it's got a lot of interest from military, from healthcare in particular, and others. So that's another potential thing that we're talking about with respect to lighting controls. Now, I'm gonna sort of close this out with a quick caution for you. There's a lot of new stuff going on out there, and I don't want to choke any of that off. I don't want to scare anybody away from things, but be careful when you are selecting lighting controls, you're specifying lighting controls. There are a couple things. If something sounds too good to be true, it probably is. And there are real potential issues with respect to longevity in some of these systems. So the example that I used to give is that if you go to Lightfair, you know, if Lightfair is anything like it's been in the past before COVID, you'll find that there are a lot of booths that advertise that they have Bluetooth lighting controls. And what that means is they've got some kind of Bluetooth app that rides on your phone and controls lighting. That's great. Sounds great. So I always ask, whose Bluetooth are you using? Because there are some that are very reputable and there are some that are just kind of homemade apps. I have a very expensive light fixture from a Danish manufacturer that I used to do a lot of custom work with. And it's color tunable. It's got red, green, blue, and white. And it used to be controlled by an app called Easy Color. Easy Color was an app that was developed by a developer in Hong Kong and stopped being supported in 2016. Well, it's 2022 now. So as of 3 years ago, that app no longer worked on Android phones. So, you know, I have an $1,100 brick. Fortunately, the manufacturer made good with me, sent me a new fixture with a more reputable module from a company called Kasambi. So I now have the ability to control my light again. But if I hadn't been a high-end lighting specifier with a fair amount of pull in the industry, I probably would still just have a brick. Now, there is a company that just last week was making news called Insteon. Insteon, I will confess, I didn't really know Insteon very well because I don't do a lot of home lighting or lighting controls. But Insteon was a company that did home automation, right? Not just lighting controls, but smart thermostats and all that other stuff. And a lot of their control resided not locally, but in the cloud. So when the company went belly up, the cloud servers got turned off and all of the advanced functionality went away without any notice at all. So all I'm telling you is be careful about looking at new technologies. Be careful about new companies. Some new companies are great. They're fantastic. Just pay attention to what you're doing when you go out there, because in some cases, it's still a bit of the wild, wild west. So that is the last of what I actually have prepared to talk to you about. So let me tell you a couple of other things. And I'm going to just advance my slide here. This is your opportunity. I'm going to go through now a few other resources, things that are available for you. But if you have any questions at all about anything we've talked about, either of the 2 days, this is your opportunity to go ahead. Please go ahead and type them into the chat now. In the meantime, while hopefully some of you are typing those questions, a reminder, we have a lot of resources available at lightingdesignlab.com/resources, a variety of different best practice guides for network lighting controls and Luminaire level lighting controls, including some videos. So there's a lot of stuff here that you can go ahead and send even your clients to, right? If they need to understand what LLC happens to be. And late breaking, I don't have, apologies, I don't have a thing for it here, but John Wilson, a fellow who used to work with us at the lab, has also put together a subsequent series of descriptors for LLC that are quite excellent. Apologies, I don't have the URL here, but if you go to NIA's website, Better Bricks, or just nia.org, you'll be able to find a link, I believe, to all that information because he did it on their behalf. You can also go ahead and download, this is a great sort of little study here, that Kevin Vanden Wijmelenberg down at University of Oregon put together a study for NIA with respect to the differences between one-for-one replacement with LLC versus NLC. I'm going to say that, like most studies, it's not perfect, but it does give you a pretty good sense that LLC is a good way to go on a lot of projects and can be very, very simple to do. And of course, we have the Lighting Design Lab. And there are some additional classes coming up, particularly with respect to network lighting controls. So next week, Dwayne Johnlin, Ben Rausch, and I will be talking about energy and alterations. So we've had a significant number of discussions about the new Seattle Energy Code, some of the implications, some of the ways to meet it already. This is a specialty subtopic about some of the requirements for alterations for buildings that already exist that are going to have changes made to them. And it's going to talk about lighting and electric and HVAC and all these kinds of things. So it'll be here next week, 10 to noon. And the following week, I'm going to do a specific network lighting controls class for healthcare. So some of the specific concerns, requirements, things that we might want to talk about with healthcare. And following that, we are going to rotate back into a little bit about heat pump hot water heaters for healthcare. Then we'll talk about commercial refrigeration and building automation systems. So if you're interested in those things, go to the lightingdesignlab.com education page, and all of that stuff will be listed in there. And of course, you are welcome and highly encouraged. If you have more questions, contact me, Shaun Darragh at seattle.gov. There's my direct office line that usually can find me, a variety of things. So I'm not seeing any other questions, so I'm going to give you another opportunity. I'm going to encourage you, any other questions that you might have, anybody at all. Questions, questions, questions. All right, well then with that, I am going to say, once again, reminder, we are here thanks to the good graces of Seattle City Light. And please go ahead and take the online survey when you leave the webinar. We really, really, really appreciate any feedback from you guys, particularly on topics that would be useful for you to hear more about in the future. Please go ahead and just put those in some of the open-ended questions that are in that. Otherwise, I will bid you a good day and thank you. I hope that this has been very useful for you, and will help you to specify, install, program, whatever it happens to be, network lighting controls in the future. So, ciao, ciao, everybody. Thanks for coming.